Hello, everyone. Welcome back. So today we're going to do a sort of a demo example, but we're going to talk about a really important concept in object-oriented design called polymorphism. So polymorphism actually is a medical term. It came from, I believe I'm not a medical expert, but some viruses that could actually take different shapes depending on what host they were in, right? So poly means multiple, morph means shape. So that's where the term comes from. So what does that have to do with object-oriented design? Well, it actually has a really interesting connotation in object-oriented design. Let me quickly review what we did last time so you can kind of see what we're going to talk about today. So this is the example that we did last time when we were talking about classes and subclasses. And if you remember, and if you have missed that video, I'm going to put a link to it over here. But one thing that we are going to do is we're going to talk about how these classes and subclasses could come into play when you have multiple different kinds of things at the same place. So here's the problem. Let's say I'm going to put this problem in the context of this traffic light flowing example that we're going through. So we've got two traffic lights here. One that uses one type of technology, three LED lights, and the other one that uses a different type of technology. It's pixel, an RGB LED. So you can think of a real world example where you have traffic lights that come from two different manufacturers, and they have different things that they do, different specifications. So you need to provide different levels of currents and things like that. But now you have a system where you are putting in these traffic lights from different manufacturers. Well, when you want to control them, what are you going to do then? Every time you connect to a traffic light to turn it on or turn the red light on, you have to figure out what kind of traffic light it is, and you have to send in specific type of currents and stuff based on their specification, right? With object-oriented design, we could actually use the idea of polymorphism to make this really simple. And today, just to have some fun, we're actually going to create a third type of traffic light. If you guys we obviously have the LEDs, individual LEDs. We have an RGB LED, and a very popular type of lighting that is also available in a lot of kits are these light strips. And you guys probably have seen some of these. If you have Christmas lighting or accent lighting, you can easily go on Amazon and buy light strips that have 10, 15, 20, 100, 200 lights connected together. What is really cool about it is that all you need is one I/O pin to control all of these LEDs individually. And the magic behind it is that each LED actually also has a control chip in it. So there are different types of RGB LEDs that are available. Some of them do have the control chip, which means you can control them individually. Some of them don't have the control chip, which means all the LEDs in the strip will show the same color depending on what signal you are sending it through. So what we're going to do today is we're actually going to create a light strip or a traffic light using this light strip. Okay, and these in Raspberry Pi terms called NeoPixel. So if I type NeoPixel, there are three different options in the simulator. There's this cool NeoPixel LED ring, but it already has a circular shape, which doesn't quite work very well with traffic lights. So we're going to actually individually create a NeoPixel light strip. We only need three, so I'm only going to create three of these. So I'm going to create another one. I guess I could also copy paste them, but just go ahead and create one more. All right, so now I've got three neopixels. Now, what is nice about these is that not only that they have a chip inside, they also have the necessary current limiting resistance built in. So you do not need to worry about, adding these current limiting resistance that we had to do for light strips. And also, these LEDs can be daisy chained one after the other. So basically the way they work is they have a data in pin and a data out pin. And of course, the other two are the VDD, which is the where you connect the power. So we're gonna create a VCC symbol, which is basically anywhere you get 5 volts. I think these do require 5 volts. You can probably drive them with 3.3, but I would suggest driving with 5 volts. Also, if you have tons of these, you probably do not want to drive them directly from the power output of the Raspberry Pi. You probably want a different power supply to drive all the LEDs because obviously they are going to take quite a bit of current. All right, so what I'm going to do is wire these up real quick. So let's wire the power pins. And we'll wire the third power pin. All right, I'm also going to wire the ground pin. And I can connect this to any ground pin I want. Let's just use the proper symbol. So black wire for ground and red wire for power. That's pretty common. Now what we're going to do is we're going to daisy chain these guys, okay? So let's say this is my primary input. I'm going to take the output of this guy and pass it into the input of this one. Same thing, output of this guy, we're going to pass that into the input of this one. Now, if you already have a um, a light strip like this one, all of that connection is already built into it. So if you look closely at the wiring, you're going to see that happening, that connections are already done for you. So you do not have to do all of these wirings in here. The strip already has the wiring. All you need really is one wire. So what we're going to do is take the first one that we want to control, and we're going to connect that to pin 2 of the Raspberry Pi Pico. And I'm going to take this and connect it to the first one. Let's make this a little cleaner. Also, let's change the color of this a little bit so that we can see where that light is going. I kind of had to go over this one because I'm already getting a little crowded. All right, so now that we've got the hardware connected, let's get the software. Now, in order to control the NeoPixel strip, we are need to add another class to our system, and that one is called light strip. So if you this is also available from the Pico library that I created, and I'm going to put a link to it if you do not have that already. But we're going to be, in many of our examples, we are going to be using this library. So here is the Lightstrip class, and let's take a quick look at what Lightstrip looks like. And Lightstrip is actually a subclass of light, as you can see here. And which means it has an on, it has an off, it has a flip. It should have a blink, or if it doesn't have a blink, it just inherits the blink from light. But what it does have is these special methods. One is called set color, and that sets the color to a specific color, very similar to the pixel class. But here, it also takes a number of pixels. So if you have 100 pixels, you can set only the first 10 of them to a specific color, for example. So that's what this one does. Then there is a set pixel. That's the one that's really nice. You can actually take a pixel number. So pixel numbers start with 0, just like an array. And you can say what color you want for that pixel. That's really nice to have. Okay. So that's what that does, that class does. Now, let's just go ahead and create a subclass of our traffic light, which is very similar to the pixel traffic light, but it's going to use the neopixel or the light strip. So I'm going to take a copy of that. Again, not very nice to do copy and paste, but since we're doing a quick video, it's not such a big deal. Again, this is going to be my light strip traffic light. And that is, again, a subclass of traffic light. And this one does not need 3 pins. It only needs 1 pin, right? Just a single pin. And what we are going to do is we are going to create a light strip. And if you notice that light strip takes a pin, a name, and number of LEDs, and that's the important part. And it also takes a brightness. So since this is a traffic light, we want full brightness. All right, so what we're going to do is we're going to create light strip. So let's call it light strip. And that one is no longer a pixel. It is basically a light strip. And it takes in the pin. We're going to give it a name. I don't know, light strip. I'm not very innovative today. Number of pixels, that's important, num LEDs. And that's only 3 for us. And we're going to send the full brightness. All right, so that creates our light strip. And now, instead of setting the color to red, we're going to say light strip dot set color. We're not going to do set color. We're going to say set pixel. Let's say we will make this one red, this one yellow, this one green. So what we will say is set color, set pixel on 0 to red. Same thing here. We will say light pixel 1 to yellow, and set pixel 2 to green. Now, one thing that we do need to do is that before that is just going to change the color of whichever one that you are doing, but we do want to turn everything else off first. So what we will do is self.lightstrip.off so that everything turns off and then the red light comes on. So we do need to make sure we do that. Otherwise, we're going to have multiple lights come on, which is going to be confusing. All right, so that's it. That's basically our subclass of traffic light, but this one uses a light strip. So now let's see how this works out. So what we're going to do is in the main, we will do that. Instead of this, we're going to say light strip traffic light. And we're only going to use pin 2. That's it. And then we will operate just like before. So let's see what happens. We're probably going to get some error message and we will fix it. So let's run it and see what happens. Yes, got the error message saying light strip traffic light isn't defined. So let's make sure traffic light, we called it, light strip traffic light, sorry. Yeah, Python is very case sensitive. So we called it light strip traffic light. So we need to call when you call the class, you need to use the same case structure that you use. All right, let's run it again. Oh, more errors. Let's see. Name error, light strip isn't defined. Oh, right. So in the in the traffic light.py, we do need to import from light strip import stuff. All right. So that would make sure that light strip is available to my traffic light.py. All right, let's see. Oh, more errors. Light strip has no. This is actually one of the most common errors that you could do in Python. Look what I did. Look at the error message. It says object has no attribute light strip. I'll give you 2 seconds to see if you can notice the error. I misspelled right? And that is actually super common. If you make a typo, you're going to get an error and you're going to be staring at the error for a long, long time. So let's figure out where we did that. Oh, multiple places. I guess I need more coffee this morning. All right, so let's go ahead and run this again. Ah, still more errors. Okay, line 82. Oh, I really could not spell today. All right, one more time. Let's hope this time it runs. There you go. Green, yellow, red. Okay, the yellow looks a little funky, but hopefully when we put it in the actual hardware, it'll look a lot nicer. So now it looks like our traffic light is working well. Well, that's all great and all, but what does all this have to do with polymorphism? So here is what we are going to do now. We have 3 traffic lights from 3 different manufacturers, and we want to control all of them together. Okay? Now watch how simple it is because they are all subclasses of traffic light and they all implement the operate method. We can use polymorphism. So instead of having 1 traffic light, now we're going to have 3 traffic lights. So I'm going to create an array, my traffic lights. This is going to be 3 arrays, 3 traffic lights. One will be the standard traffic light, which is going to have just the 3 red, yellow, green pins. And that, let me make sure, 6, 7, and 8. So that's my first traffic light. Then I'm going to have a second traffic light. That one will be the pixel traffic light. And that's going to be on pins 3, 4, and 5. And there is a third traffic light, which is my light strip traffic light, which is going to be on pin 2. All right, so now I've got 3 traffic lights, and we're going to operate all of them together, right? So now what we're going to do is we are basically going to do another while loop that goes through all of these traffic lights, and we will say for TL in my traffic lights, and then just TL.operate. Do you see how beautiful that is? This for loop is going through all of these traffic lights, and it's going to call the operate on the method because they're traffic lights, right? They all implement operate, and they have their own implementation. So the compiler or even the programmer does not need to think about, any logic that they have to do things differently for the different traffic lights. So let's run this and see this in action. So we're going to run this. Hopefully no more errors. We should first see this traffic light operate. Great. Now it should go to that one. There you go. Right? And then now it should go to this one. how beautifully they all work. And we didn't have to do any additional thing other than just implementing the classes. Of course, this is not how standard traffic light systems work, but as you can see, it sort of works the proper way that these two are red when once this one becomes red, another one will turn green. And now this one is green. And then when this one turns red, this one will become green and so forth. So three different traffic lights from three different manufacturers operating with basically same line of code with no problems at all. And that's the power of polymorphism, allowing subclasses that implement the same method to work seamlessly together. You can put all of them in one array. You can treat them basically the same without any problem. So hopefully you understood that pretty well. Um, and we could actually take a second to implement this in the hardware itself since I have it all connected. So let's go ahead and do that. And I might just sort of time lapse through the process. Okay, now I have the files downloaded to Tony and copied to my Pico. So now let's see how this works. So I'm going to run this main app. We should see first the regular traffic light go from green, yellow, red, and then we will have the pixel traffic light go from green, yellow, red, and then our light strip traffic light go from green, yellow, red. So now you see just with one single line of code, essentially, we are with no additional logic. We're not checking what kind of traffic light it is. We're just calling operate, and polymorphism will take care of which operate to run depending on what kind of class it is. And that's the power of polymorphism, allowing us to put different types of objects in one place. So, and the operate is just going to take different shapes depending on what kind of object it is in. Hope this was useful. Hope you learned something new today, and we will see you in the next video.